Hello da Tanga, welcome to Gully Classroom. This is the second lecture. In which chapter, sir? In the chapter Light, Reflection and Refraction. In CBSE 10th Standard Physics, Science Book Chapter 10 Light, Reflection and Refraction. This is the second lecture taken in English. This is the second lecture taken in English. Okay, sir. What are we going to learn in this particular lecture? In this particular lecture, we will learn about how will concave mirror and convex mirror react with the ray of light. We will have an introduction about law of reversibility of light, and also we will see for what kind of spherical mirrors a particular formula, radius of curvature is equal to twice of focal length, is applicable. These are the three things that we will cover in this particular lecture. Can we get to this lecture? Yes, sir. But can you do one thing, sir? Yes, Kana, please tell me. Can you do a very short recollection of what we have already learned in the first lecture? Okay, let me do a very short recollection. First, a mirror that is cut from a spherical surface is called as a spherical mirror. There is a large spherical surface, you are cutting a circle out of it. This particular circular mirror, which is in fact slightly curved inwards or curved outwards, is called as a spherical mirror. Okay, sir. Okay, sir. If, let me tell you, if the curved surface is polished, if the inside curved surface is polished, it is called as a concave mirror. If the outside curved surface is polished, it is called as a convex mirror. Okay, what then, sir? The center of the sphere from which the mirror is cut is called as center of curvature. The radius of the sphere from which the mirror is cut is called as radius of curvature. Okay, sir. Kindly draw this and show me. Kindly draw this and show me. Absolutely. Let me draw a concave mirror. So in a concave mirror, the polished surface is curved inwards. Let me draw the principal axis. Okay, so the center of the mirror is called as pole. This curved concave mirror is a part of a very large circle, is a part of a very large sphere. It's a part of a very large sphere. Okay, sir. The center of the sphere is called as center of curvature. What next, sir? Concave mirror, we have already studied that it is a converging mirror. Concave mirror, we have already studied that it is a converging mirror. So what is the nature of the concave mirror? The nature of the concave mirror is that when light rays are coming parallel to the principal axis. Sir, I have a doubt. Yes, Tangam, please ask me. What is principal axis? The straight line that is joining the center of curvature and the pole of a mirror, of a spherical mirror, is called as principal axis. When light rays are coming parallel to the principal axis, these light rays are in fact reflected to a specific point on the principal axis, which is called as principal focus. This focusing of light rays happens only in concave mirror. This focusing happens only in concave mirror. Yeah? Okay, so these light rays are focused at a particular point. Okay, sir. Okay, sir. So this is called as principal focus. What is the distance between the principal focus and the pole? It is called as focal length. This distance is called as focal length. It is indicated by small f. What is the distance between the center of curvature and the pole? The center of curvature and the pole, the distance between them is called as radius of curvature. It is represented by capital R. Radius of curvature. It is represented by capital R. Okay. Now let me tell you something interesting. The only type of mirrors we are going to study in our syllabus are going to be defined by a specific property. What is the specific property by which these mirrors are defined? The radius of curvature is always very greater than aperture. The radius of curvature is always very greater than aperture. Sir, I forgot what is aperture. Kindly do a very fast recollection for me. Aperture means the diameter of this spherical mirror. So you have a spherical mirror. This spherical mirror has the center which is called as a pole. If the polished surface, reflecting surface is curved inwards, it is called as a concave mirror. The diameter from this end point to this end point of this spherical mirror is called as aperture. So according to our idea, according to our limited syllabus, we are going to study only those spherical mirrors which have very less aperture when they compare to the radius of curvature. For example, if I have a sphere which is very large, if I have a sphere that is more or less the size of the room that you are sitting in, if I have a spherical mirror, if I have a sphere which is more or less the size of the room that you are sitting in, if I am going to cut a spherical mirror out of it, if I am going to cut a spherical mirror out of it, then that is basically what is happening in our syllabus. This mirror is actually a part of a sphere that is very large in size, that is very large in size. Only in those conditions what will happen? I can write that radius of curvature is nothing but twice of focal length. This is a limiting condition. We are going to study mirrors which only obey this particular law, where our radius of curvature is equal to twice of focal length. Kindly look here. This is one focal length, this is one focal length. Here F or principal focus is right in the middle of center of curvature and pole. Is right in the middle of center of curvature and pole. Are you able to understand the concave mirror? Yes sir. Let us do a very short recollection of a convex mirror also. Absolutely Tango. Let us say this is a convex mirror. Okay, now I am drawing a convex mirror. I am drawing a principal focus. Obviously, the convex mirror is a part of the sphere. That sphere has a center over here. This is called as center of curvature. In between the pole and the center of curvature, right over here, there is your principal focus. There is your principal focus. We know that convex mirror is a diverging mirror. Okay. So what does a convex mirror do? It diverges all the light falling on it. We are going to use green color for light. So a parallel beam of light, parallel to what sir? Parallel to the principal axis, will be reflected from the focus, from the principal focus behind the mirror. So I will draw dotted lines from here and I will draw a straight line. What next sir? In a similar way, a light ray which is parallel to the principal axis will be reflected, will be diverged, because convex mirror is a diverging mirror, will be diverged in such a way that it is coming out of the focus that is behind the convex mirror. Parallel light rays to the principal axis in a convex mirror will be diverged in such a way that they are coming from the principal focus which is present behind the convex mirror on its principal axis. Yeah, I can draw any number of rays. I can simply draw any number of rays. It will be diverged such that it is coming out of. It will be diverged such that it is coming out of my principal focus. Are you able to understand the basic terminology behind the concave mirror and a convex mirror? Here this is the focus, the principal focus, the point from which the light rays parallel to the principal axis of the convex mirror seem to be diverging from. Yeah, okay. Now that is basically the idea behind concave mirror and convex mirror. Concave mirror and convex mirror. Now we know the limiting condition for all the mirrors we are going to study in this subject. What is the limiting condition? We are going to study only those mirrors for which radius of aperture is radius of curvature is very greater than aperture. For such mirrors we can write that capital R is equal to 2f. We can write that capital R is equal to 2f. Okay sir. Now what are the basic rules? Using which light rays in a concave mirror and a convex mirror can be drawn. There are some basic rules using which you will be able to draw the light rays in a concave and a convex mirror. Let us go through those rules together. Okay, sir. What is the first rule? Let us take a concave or a converging mirror. Okay, sir. Let me take a concave or a converging mirror. Okay, then what? I am going to put a concave or a converging mirror like this. I am going to have my principal axis. This is going to be my pole. This is going to be my center of curvature. In between center of curvature and pole, I have my principal focus. Now, each and every light ray that is coming parallel to the principal axis will be sent through the focus. This is the first idea. Each and every light ray that is coming parallel to the principal axis will be sent through the focus. Okay, sir. Okay, sir. Now, let me ask you one particular question. One more concave mirror. Here there is the pole. Here there is the center of curvature. In between the pole and the center of curvature, I have my principal axis. Let us say, if I have a light ray which is going through the, principal focus, what will happen to it? This light ray will get reflected such that the reflected ray is parallel to the principal axis. This light ray will get reflected such that the reflected ray is parallel to the principal axis. Yeah? Okay, sir. So, if a light ray is coming parallel to the principal axis, it will always pass through the pole. In the same way, a light ray which is passing through the pole will be reflected in such a way that it becomes parallel to the principal axis. Sir, I have a doubt. Please ask Sami. Here, isn't light following its own path? Here it is coming like this and going like this. Once more, if you reverse the path of light, it is going like this and coming like this. Yes, this is called the law of reversibility of light path. Let us say light takes a specific path like this. Okay, sir, I am understanding. It is coming like this, getting reflected and going like this. If you are inverting the path of light, light will follow the same path in the opposite direction. Light has the nature to follow its own path in the opposite direction. This is called as law of reversibility of light. This is called as not raw. It is not raw. It is law of reversibility. Law of reversibility of light. Are you able to understand this particular idea? Absolutely, sir. Okay, so light, if it is going to come parallel to the principal axis, it will pass through the focus. If it is going to come through the focus, it is going to become parallel to the principal axis. In a similar way, if it is going to pass through the focus, it is becoming parallel to the principal axis. If it is coming parallel to the focus, something like this, then what it will happen? It will pass through the focus. Okay, sir. Now I am able to understand. Now, where do I draw the normal to this particular diagram? First, let us recall what is normal. Let us say this is a reflecting surface. If I draw a line that is perpendicular to the reflecting surface, it is called as a normal. And also, let me recollect something very, very important. Let us say this is the incident ray, this is the reflected ray. So, this is the incident ray and this is the reflected ray. What is this? This is angle of incidence, this is angle of reflection. This is angle of incidence and this is angle of reflection. As my incident ray moves towards the normal, my reflected ray also moves towards the normal. At some point, if my incident ray is along the normal, what will happen? My reflected ray will also become along the normal. What is the understanding behind this? When a light ray is going along the normal, it will be reflected along the same path. When a light ray is going on the same line as the normal, it will be sent along the same line. Sir, how am I supposed to understand this? Here, theta I is equal to theta R is equal to 0. Angle of incidence and angle of reflection are 0. Why, sir? Angle of incidence is the angle between incident ray and the normal. Here incident ray and the normal are one and the same line. So angle of incidence is 0. Angle of reflection is the angle between the normal and the reflected ray. Here the normal and the reflected ray are one and the same. So once more the angle of reflection is 0. Are you able to understand this particular idea? Yes, sir. Now let me ask you a question. Where do you draw a normal in this particular spherical mirror? It's an interesting question. Kindly illustrate. Okay, let us take a circle. Okay, I need to draw a line that is perpendicular to a point on the circle. How am I supposed to do this? This particular line is called as a tangent. What is a tangent? A tangent is a line that is going to meet the circle only at one point. A tangent is a line that is going to meet the circle only at one point. So this is called as radius. So radius and tangent are perpendicular at its point of contact. Sir, where am I going to study this? You are going to study this concept in a chapter called as circles in your 10th standard mathematics. There is a proof for this. We will see the proof in that particular point. Anyway, here the radius and the tangent are at right angles to each other. The radius and the tangent are at right angles to each other. So whenever I am going to draw the normal, I will simply put a line that is passing through the center of curvature. Whenever I am drawing a normal, I will simply put a line that is passing through the center of curvature. If the line is passing through the center of curvature, it is automatically at right angles to the tangent. Okay, sir. Here there is center of curvature. Let me put a line that is passing through the center of curvature. Okay, so this is my line. If this is my line, what is my angle of incidence and what is my angle of reflection? Kindly illustrate in both these conditions. Absolutely, Tanga. Here, this is my incident ray, this is my reflected ray. Angle of incidence is the angle between incident ray and the normal. So this is theta I. Angle of reflection is the angle between reflected ray and the normal. So this is theta R. Okay, what about here, sir? Here, let me first draw the normal. The normal must pass through the center of curvature. What next, sir? What next? Let me draw the incident ray. The incident ray is passing through the focus. So the angle between the normal and the incident ray is angle of incidence. The angle between the reflected ray and the normal is angle of reflection. So angle of incidence is equal to angle of reflection in this case also. Okay, sir. Let me ask you a very interesting question. Please do so, Tangam. Here I want to know what will happen if a light ray is passing through the normal, which is basically a line passing through C. Let me draw a center of curvature. Over here there is a center of curvature. Okay, sir. What next? In here there is the pole, which is the center of the spherical mirror. In between the center of curvature and pole, I have the principal focus. Now, let us say I have a ray. This ray is simply passing through C. Now, what will happen? This light ray, after reflection, will be reflected once more along the same path. Here, in this condition, what is happening? In this condition, theta I, angle of incidence, is equal to theta R, angle of reflection. Both are equal to 0. This is similar to what is happening over here in a spherical mirror. In a spherical mirror here, angle of incidence, in a plane mirror here, angle of incidence and angle of reflection are becoming 0. In a similar way, in a spherical mirror here, because the light ray is passing through the path of the normal, the angle of incidence and angle of reflection is 0. So if a light ray is coming in this particular path like this, it will be reflected in the same path like this. Are you able to understand this particular diagram? Okay, sir. Okay, sir. Now let us go for another diagram where I want to know what will happen if a light ray is hitting the pole. I want to know what will happen if a light ray is hitting the pole. Okay, Kanna. So this is your pole. Okay, sir. So let me draw the pole. Here you have your center of curvature. In between your pole and center of curvature, you have your principal focus. This particular light ray is coming at an angle to the pole. Okay, so this is called as angle of incidence. Sir, why is this called as angle of incidence? Angle of incidence is the angle between the incident ray and the normal. Here the principal axis is acting as the normal. Here the principal axis is acting as the normal. Okay sir, now what is happening? This incident ray is hitting the pole and getting reflected like this. So this is going to be called as angle of reflection. This is going to be called as angle of reflection. Okay, are you able to understand this particular diagram? Okay sir, here angle of incidence and angle of reflection are equal. Let me ask you a question. According to the law of reversibility of light, if I am going to send a light like this, what will happen? It will follow the same path and come out like this. It will follow the same path and come out like this. Because of this, drawing arrows and each and every light ray is very important. If you are not drawing arrows and drawing a light ray, you are simply not indicating the direction in which the light ray is going, and that is a fatal error. Okay sir, I am able to understand how light rays are getting reflected in a concave mirror. What about a convex mirror sir? Absolutely, let us go for a convex mirror. In a convex mirror, yeah, the reflecting surface is bulging outwards. So the center of curvature and focus is outside, is behind, not outside, it is behind a polished surface of a convex mirror. So this is center of curvature, this is your pole, this is your principal focus. Once more, let us draw the same diagram. Here this is your pole, here this is your center of curvature, this is your focus. Let us do this once more. Here this is your pole, yeah, this is your, this is your principal focus, this is your center of curvature, this is your pole. Okay sir, now let us draw each and every diagram for each and every given condition. First let us draw for a parallel line. A parallel line, a line that is parallel to the principal axis, will be reflected in such a way that the diverging ray will seem to come out of the focus. The light which is parallel to the principal axis in a convex mirror will be reflected in such a way. How will it be reflected? From which point will it be reflected? It will be reflected in such a way that it comes from a particular point on the principal axis, which is called as focus. Okay sir, okay sir. Now from C, let me draw a line. From C, let me draw a line. Okay, this particular line is called as normal. Here this angle is called as theta or theta I, angle of incidence. The angle between incident ray and the normal is called as angle of incidence. The angle between reflected ray and the normal is called as angle of reflection. This line I have drawn it slightly wrong. If you would have drawn it exactly correctly, it will be perfectly beautiful. It will be something like this. Now theta r and theta I are more or less equal. Yes, theta I and theta are more or less equal. Sir, now let me ask you a question. Absolutely, if the light is going to come in such a way that it is coming at the focus, if the light is coming at the focus, what will happen? It will become parallel to the principal axis. If the light is going parallel to the principal axis, it will be reflected in such a way that it is getting diverged from the principal focus. If the light is going through the focus, it will be reflected in such a way that it is passing like this. In that particular condition, this will become my angle of incidence. This will become my angle of reflection. But anyway, according to the law of reflection, both angle of incidence and angle of reflection are going to be equal for reflection on any surfaces. It can be a spherical mirror, it can be a plane mirror, it can be a jagged surface. For any type of reflection, a reflection that takes place anywhere, the law of reflection always holds true. Angle of incidence is always equal to angle of reflection. Okay sir, okay sir. Now what will happen if a light ray is coming in such a way that it is coming and hitting C, such that it is coming and hitting C? If a light ray is coming like this, what will happen? It will be reflected in the same path. A light ray which is passing through the normal of a convex mirror will be reflected along the same path. In this condition, theta I is equal to theta r is equal to angle of incidence is equal to angle of reflection is equal to 0. Okay sir, what will happen if the light ray is coming in such a way that it is hitting at the pole? it will be reflected in such a way that the theta angle of incidence is equal to theta or angle of reflection. Also, in this case, the path of the light can be reversed. If a light is coming like this and coming like this, angle of incidence is here, angle of reflection is here. If I am doing path reversal, then angle of incidence will be here and angle of reflection will be right over here. The light will simply go like this and come like this. Are you able to understand what is happening with respect to reflection of light in concave mirror and convex mirror? Okay, sir, I am able to understand this. Right, Tangam. Now you might have a doubt here. What doubt, sir? The doubt is how many light rays are needed in order to form an image? The minimum number of light rays that are needed to form an image are 2. Sir, how are you understanding this? Are you able to see me? Yes, sir. Why are you able to see me? Light from a source is throwing millions of light rays towards me. Each and every point in my face, each and every point in my hand right now are illuminated, are lighted up by millions of light rays. Are illuminated by millions of light rays. Okay, sir. These millions of light rays, what is happening? They are meeting together and forming a image. These light rays are meeting together and forming a image. Okay, so light rays need to meet in order to form an image. How many light rays do you need to create a single point? How many light rays do you need to create a single point? I need at least 2 light rays. I need at least 2 light rays to create a single point of reference for a image. So how many light rays do you need to form a image from an object? From an object to a image, I need at least, not just myself, any good physicist needs at least 2 rays of light, and the point of contact of these 2 rays of light will be taken as the reference point, using which will be taken as the reference point using which the image is constructed. Are you able to understand this? Yes, sir. Okay, Tango. In the next lecture, is going to be very important. We will study about at what positions objects are forming what kind of images in concave mirror and convex mirror. In concave mirror and convex mirror. Yeah, I hope you guys enjoyed this lecture. I hope I didn't bore you guys too much. Yeah, cheers and thank you for listening to me. If you guys enjoyed my lecture, do kindly recommend our channel to other fellows, your friends, your like your neighbors, and whoever these videos are going to be useful on the internet. Why, sir? Because we are going to have so much fun learning physics, chemistry, biology, economics, maths, each and every subject together in the internet, in our channel at Gully Classroom. Cheers and thank you for listening to me. See you guys in the next lecture. Cheers and thank you for listening to me. See you guys in the next lecture.